What do NASA, McLaren, and the restaurant Sushi Singularity have in common? They have all incorporated 3D printing or additive manufacturing into their work in some form or another. 3D printing is bringing many changes to a number of important industries. Companies have begun printing everything from fully functioning cars to Michelin-starred dinners. Medical research institutions have even experimented with printing functioning body parts, paralleling some of our favorite science fiction shows. Recently, additive manufacturing showcased its practical versatility, becoming a powerful tool in tackling some of the unprecedented challenges posed by COVID-19, helping to supply health workers with personal protective equipment and patients with ventilators. So is the 3D printing revolution here to stay, or is it merely a trend? For the uninitiated, 3D printing is the process of making solid three-dimensional objects from a digital file, also called additive manufacturing. 3D printing centers around layering materials like plastics, composites, or biomaterials to create objects that range in shape, size, rigidity, and color. Manufacturers and enthusiasts can print aluminum parts, human tissue, carbon fiber tools, thermoplastic figurines, and even dental models. There are currently 9 basic types of 3D printing, with SLA, FDM, and SLS printing being the most common. 3D printing is the opposite of more traditional subtractive manufacturing, which usually involves cutting the final object out of a piece of metal or plastic, using, for example, a milling machine. The first 3D printing technologies made their appearance in the early 1980s. They were expensive, difficult to use, and generally inaccessible to people who lacked specialized training. Yet 3D printing has been a common trope in science fiction, appearing as early as the 60s in the work of Arthur C. Clarke, and sporadically in Hollywood classics over the decades. Films like Darkman and Westworld even predicted the printing of human body parts. Some even argue that 3D printing is the closest we can get to Star Trek's Replicator. After the patent behind a key method of 3D printing, fused deposition modeling, expired in 2009, prices for FDM printers dropped from more than $10,000 to less than $1,000, allowing consumer-friendly 3D printer manufacturers to pave the way for accessible 3D printing. According to Acumen Research and Consulting forecasts, the global 3D printing market is expected to reach $41 billion by 2026. Today, in some industries, companies who have yet to integrate additive manufacturing somewhere in their supply chain are now part of an ever-shrinking minority. What makes additive manufacturing so appealing? It gives manufacturers the ability to rapidly prototype and even rapidly manufacture crucial products or components. 3D printing also enables the production of complex shapes using less material than traditional manufacturing methods. This has the potential to slash manufacturing times and costs. It also has the potential to innovate in a wide number of manufacturing areas. NASA and affiliates like Relativity Space are not only 3D printing crucial rocket parts, but they also believe that additive manufacturing will help us colonize Mars and other planets beyond. The US-based construction technology company Icon is using proprietary 3D printing robotics to build homes in impoverished areas around the world. Companies like New Balance are looking to not only use additive manufacturing to improve their products, but to create custom apparel. This is all just the tip of the iceberg. Manufacturing as a whole is expected to experience the most dramatic changes. Some of the more obvious benefits include reduced costs, faster product development, precise prototyping, and improved customization. Yet 3D printing is not a one-size-fits-all solution for all industries. In fact, in some industries, 3D printing is more costly than traditional manufacturing methods. The type of materials that can be printed are limited, and printing can quickly become more costly than traditional manufacturing. Moreover, 3D printing on a large scale is still far less efficient than traditional processes such as injection molding. 3D printing is not going anywhere. If anything, you are going to see the technology used to produce an increasing variety of goods. In fact, this emerging technology continues to attract large investment from companies and research institutions because of its potential application to almost every industry. Additive manufacturing cannot be simply written off as a trend. However, we are not yet at the point of printing clothing and food at home on command, like the Replicator from Star Trek. In fact, the incoming 3D printing revolution is much more likely to change the way industry works, long before it changes how we purchase personal consumer goods. But this does not make the technology any less exciting. 3D printing is still a place where engineering and science fiction intersect, potentially taking manufacturing to new heights. What would that future look like? 3D printing would take us beyond the assembly line, providing a significant reduction in the cost of components, eventually leading to on-the-fly innovation. Even more so, we would be able to reduce industrial waste, try more experimental designs, produce finished products much faster, and create hyper-customizable parts. Restaurants would be able to 3D print dishes that are not just based on your preferences, but on your specific biologic makeup. You would see it used in the acceleration of space programs around the world, with additive manufacturing becoming a key component to the future construction of our space colonies. Doctors would be able to print custom-made prosthetics and organs after an injury. Clothing stores would allow you to order designs and print them from the convenience of your home. This future is not too far off. How do you think 3D printing will impact your future? And do you think 3D printing's impact matches its hype?